recording here, and okay, so the general title, or basically the name for the field that we're going to be talking about today is called machine learning. All right. There are many ways to express machine learning, and there's no fixed definition for it. It changes from time to time. But I found this to be one of the best short definitions of it. And it's basically a set of ideas that are applied through computers, obviously. Okay, so it's not like a theoretical methodology. It is not, like a theory that you'll find in a textbook. It's basically an application-driven idea for computers. And the algorithms involved basically teach the computer by example instead of hard coding a program. Okay, so every time you have a situation where you can teach the computer right from wrong, left from right, or whatever by giving it lots and lots of examples, that is called machine learning. Okay? Now, sometimes you have to code that in. Sometimes you grab a package and throw it in there. But instead of writing a code from the beginning to the end, you fit data to some sort of generic algorithm, and the code itself decides on the logic behind it. Okay, so you're literally using easy learning tool, and you just provide good examples. Every time you have such a situation, you're talking about machine learning, and we'll see various examples of it. Some of them are going to be with images, some of them are going to be with structured data, some of them are going to be with time series. Okay, Vihar Kurama is an expert in the field. He writes a great blog, and I've been following him for quite some time, and I thought this was a great quotation. Now, why do we need it, folks? Okay, it has been proven practically that algorithms that use machine learning ideas are better than algorithms that don't. They are what we call smarter. They can be applied to more things than just your algorithm that you created for that one data set. So these tools are basically, as we call it, smarter. They're better fits for more stuff. Think about it. If you're trying to basically program everything, you need to start thinking about all possible complicated ways that things can go wrong, all possible complications that data set has. Okay? That tends to create bigger and bigger and bigger codes. So the idea is, if you can't do that because the data is too complicated, find another way. Teach the machine how to do it without having to hard code every possible complexity. Another thing is, if you go back even 30 years, right, the data set was small enough so that we didn't really need to use elaborate tools on it. We could basically check it on our own and find all the patterns. But right now, we're talking about zettabytes of data available out there, so it is impossible for a human to just browse through all of them and identify the patterns on their own. Okay, so it becomes untractable. Even for the best computer scientists or the best statisticians, they are not able to find the pattern just by looking at the data because the data is so vast. People promote these ideas, machine learning tools, as the only answer to big data. We've noticed already some difficulties that we have when we're handling data sets that are not easy to tame. Okay? Take the problems that we faced, let's say a couple of weeks ago when we were doing that experiment, and multiply them by 100 if you're working with, let's say, 100 years worth of that data. So at some point it becomes impossible to just do all this by hand, as we say. When we reach big data realms, we must find automated ways to track everything down. The best automated ways apparently belong to machine learning. Okay. And as I said, they are very smart, so they can be applied to different things. Disclaimer here, I know nothing about agriculture. I guess I learned a bunch of stuff starting this past summer. All the tools that I've ever made in my life can be applied to all the questions in agriculture because the tools themselves are very flexible. They're not tied to a specific data set. They're tied to concepts. So just create the tools in health informatics that I was working on up until last year, and then adjust them to work in whatever else. Okay, I was writing some image analytics code back in 2013 that used fMRIs as the raw source, and now I'm using the exact same codes, and I'm using images from petri dishes that have mosquitoes in them. Right, that cannot really work if you're just using stats codes for a specific thing. You have to discard the old ones and start from scratch. Machine learning codes are so generic that if it applies successfully to images of type A, it will probably also apply successfully into images of type B, even if A and B come from completely different fields. So they're flexible, they're smart, they're easy to create, and they're also very good for bigger data sets. So machine learning tools. Another thing, here's a catchphrase that you guys should know if you're asked about it. Computers can do better and faster a lot of things that humans can. Fact of life, folks. The moment that you believe this, you can move forward. And instead of antagonizing them, use them for your benefit. Okay? A lot of old-timers, talking about tenure professors and all that, will disagree with this. And they say, oh, but you will always need an expert to do A, B, C, D. Well, give me another 20 years and I can prove that every job can be done by a computer much better. Done. Fact of life. The moment you believe that, you can move forward and you can actually be successful in this field. If you resist that, you will become obsolete sooner or later. And I have examples. Go back 50 years and look at how many jobs were done by human beings in the auto manufacturing industry. Check again this year. The auto manufacturing industry is down 67%. So 2/3 of all jobs have been replaced by a machine. And now you're going to be like, wait, but that's never going to come into my line of work. For example, if I'm a sportscaster and I write columns explaining games for whatever outlets, that's never going to be replaced. Oh wait, that has been replaced completely by machine learning tools for ESPN, for Fox News, and I think CNN also changed into that. So none of these things are written by a human being anymore. How do you like that one?
This will be a disruption on a scale never before encountered in civilization.
True statement. So what do we do?
Learn to code.
Learn to code, precisely.
Well,
we learn to be the
coders.
Yeah, we will. Imagine if we're trying to change everything to an automation. And if it takes your job, you be the person that teaches the computer how to do it. I believe my job as a teacher is going to go away pretty soon too. Because what do you need? You need a person that says it right. Okay, great. Take all the best professors ever and teach a computer how to basically talk like them. Done. And it's going to be much better than me because I make mistakes all the time. That thing is not going to make any mistakes ever. Okay? Anyway, I know this sounds a little bit, pessimistic or basically sad. It is a truth. Okay? Maybe not in 20 years, maybe not in 100 years, but there will be a time that, for example, breeding in rice does not involve any human being, or planting and growing things does not involve any human being ever. Okay. And on that cheerful note, let's move on to the next one. Now, we are at this stage, though, that we're still teaching our machines. So humans and machines is the goal for the next couple of years. Here's the idea. it's called supervised learning. So basically you, the expert, is the person that is teaching the machine through the algorithms whatever it is needed. So what you need to do is you need to be able to create annotated sets. Basically, if you're teaching the computer to figure out where are the cars in an image, you need to provide a lot of images with stuff being annotated. That's a car, that's a human being, and so on and so forth. So the human comes in the creation of the annotated sets. The human also comes in the creation of the algorithm, choosing which is the best algorithm to answer that question. But then the machine takes over and tries to do what we call prediction based on whatever you fed it. And both of them, the machine and the human, are working on improving it. Okay, so the machine is going to give out suggestions, for example, on whatever it needs. Basically, it's going to say, I'm not going to be able to understand category C. Give me more information about that. And then the human being gets on top of that. So that's the current situation. Like practically all speech recognition tools that you have out there, Siri, Cortana, Google's, whatever it's called, all of them are done through this process. Okay, the human beings have set up the algorithm, and then every time you talk to Siri, you make her smarter because you're asking for instructions, and when she gets it right, you successfully say, okay, let's go there. When she gets it wrong, you say, no, 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 that's not what I meant. So you're basically creating the annotated set as you go. Okay? And then the improvement happens on Siri's end. So once again, what's the idea here? Learn by examples, and the examples are provided by the user, the human. They're also corrected by the user and the human, and that's the type of situations that we're going to be dealing with here. They are updated by the user. So for example, a new algorithm comes out, the user is the one that switches things around, or you want to start the machine to understand more stuff, you update it. And that's basically 95% of the machine learning tools that are out there and people are using successfully in everything. Okay? And those are the tools that I'm going to focus on 100% in this class. Okay, I'm going to show you how you can create such a thing. We will have working codes for machine learning, the basic machine learning tools, neural networks, support vector machines, and random forests that you could then massage and put whatever data you want, and it's still going to work. So we're here now. The future, so we said in 100 years computers are going to do more, so in 1,000 years machines are not going to care about us at all. Right? And this is already available. There are things that are called adversarial neural networks that you basically put two computers and you tell them, go figure it out on your own. And they just do. And how does that go? The only time that you apply something to the system is in the beginning, when you create a set of rules and you basically put a preferable outcome. And then the computers themselves, the algorithms themselves, come up with their own training schemas, come up with their own validation schemas, and then they keep on updating and changing the rules until it becomes something intractable. And an example of that is actually Leela Chess 0. So what is Leela Chess 0? I'm actually I back it up with my computer from time to time. I give it hardware so that it can do its application. So Leela Chess 0 is a neural network algorithm basically that learned how to play chess and now is much better than any chess player alive. And it was never trained by a human being. So what Leela does, and I will call her a she because whatever, that's what the authors did. So what she does is she creates a clone of herself and plays against herself. Right? Keeps playing chess. Human beings take about 4 hours to play a chess game. Leela plays one in like 4 milliseconds. So imagine how many chess games she plays a day against herself. Yeah, that many. So she also has a very easy way of figuring out if the moves are correct. Did she win the game or not? Okay. Right? So it's very easy to set the rules. I mean, somebody told her how pieces move and what the basics of chess are. You can teach that to a 6-year-old. I know that's when I learned chess. Okay, so it's like a very, very fixed set of rules. And then you also tell it, go win. Okay, and then she just plays against herself and becomes smarter every time. And every time she has a stable winning schema, that becomes Leela chess version this. So then next day, she plays against herself again and creates a newer version and a newer version. So that's one way to create something that does not need human beings. So the system learns on its own, updates the rules as it goes, and it's black box magic area. You have no idea how it works. Yes, Leela Chess Zero has surpassed us so fast and in such a unique way that we just don't understand how it works. Other chess programs, we know exactly how they think. They have, we understand that it played that move because it shows you 15 moves afterwards that it wins. Okay, so they will give you the whole thread of why they're choosing that move. For Leela, she just plays stuff and just wins. She's now winning against other chess programs as well. That's important. All right. So yeah, and then after a little bit, you know what's going on. Skynet, Terminators, blah blah blah. All right. So there are two basic types of machine learning in terms of the applications. Classification, basically, is this type A, type B, type C, and prediction. Here's some data, figure out what's going to happen. I'm going to show you examples for both. Now, typical classifications examples are identify an object in a picture. Okay, that's very useful. For example, if you're using drones and you want to figure out the plots. Okay, I'm just trying to tie to some things that you've already done. Or you want to find the insect in the petri dish. That's object detection. Distinguish healthy from unhealthy plants immediately. Take a fly drone, figure out which plants are healthy or unhealthy. Fly 20 feet up, and you can do this. Identify outliers and problematic points in a field. Where's the puddle of water? Which crop is different from the rest in terms of color? Where's the pest? So on and so forth. Some people have used this as well to figure out hogs in the field.
Yeah, so now like when it's in live movie, when you see the hog walking,
Yep.
you can shoot.
You can. I don't know if you can shoot it, but you can scare it off. Let's go with scare it off. But yeah. Now the other type, which is very common, is prediction. So my favorite one would be to be able to predict yield based on field characteristics. I've done one or two examples in the past. One of them is going to be published. It does a better job than traditional statistics. It's not good, but it's better than whatever else have been tried. Of course, I'm not using any elaborate methodologies that people have devised where you're using all sorts of indices. This is just raw stuff, and you're trying a linear regression on top of it. And machine learning works much better. Predict outcome of certain agronomic actions based on past data. This is something that during the Ag Day, I heard a lot of folks asking for. Like, what would happen if I put nitrogen here? What would happen if this and that? So that is a big field right now, trying to figure out through machine learning what would happen if. So these scenarios are something that you can't really do statistics on, right? But perhaps you can use machine learning for it and find the best practices. Okay, again, this has been asked for. I'm not sure if machine learning tools are going to be able to do it, but it would fall under prediction. So maybe we can give it a try. All right, so that's a sweet intro, I guess, to machine learning. There's much, much more. I do want to talk to you a little bit about this upcoming talk this Wednesday, I believe it is. No, it's Thursday, actually. Let's see. So, yeah. So, Dr. Steve Ward, who's actually an alumni from LSU, he's working for Climate Corporation. And if you don't know what Climate Corporation is, okay, do you know what Monsanto is? Yeah. So Climate Corp is the branch of Monsanto that's dealing with digital ag. Drones, field data, they all have their own farms where they do their things combined with however many farmers they got on board. So Climate Corporation, which is based in San Francisco, has now more than 150 employees and a budget of something like 10 million, or no, I don't think it's 10 million. I think it's 100 million or something like that. Yeah, these guys are growing. So Monsanto was like, here's money, go ahead and do digital ag, whatever you can. I don't care. And they don't have any timetable for that. They just hire people to think about these things, and they're rolling out some apps, and they're rolling out some simple algorithms. So Dr. Ward is going to be here, I guess, tomorrow, and then he's going to stay until Friday. And his talk, I guess, is on March 14th from 1:45 to 2:45 in Efferson, where the Ag Center is. And I'm meeting with him Friday morning. So if you find yourself available those times, do join us. Come and see what he has to say. Perhaps you can ask a smart question right afterwards, and then Friday morning, be like, yeah, you know that guy that asked the question? He's a student of mine in that class, and he's learning all that stuff. He was very interested in the class, actually, and he wants, like, one of the reasons that he's here is because he wants to hire interns for the summer, and he wants to hire people for Climate Corp. But he doesn't want to hire a physicist. He doesn't want to hire a data scientist. He doesn't want to hire all the things that he's mentioning here. What he wants to hire is a person that's coming from agriculture and knows these things. He basically want to hire a digital ag guy. And we know that these folks don't exist yet. So he said, okay, try to tell me what's out there. And him and his company are going to work with us. They're going to give us some free software we can play around with. As I said, they're going to have these internships for the summer. And he also said that from time to time he's going to be coming in and telling us what are the types of things that they're doing over there, so we can prepare you if you'd like to go. Okay, so I think this is going to be a good collaboration. If you guys have the time, go ahead and show up there. And he may also talk a little bit more about the machine learning tools that people are using in practice. Any questions? Okay. Yes, sir.
How common is it in the state right now for farmers to be doing any sort of analysis on the data at all?
Very good.
Just like basic stuff.
So it's not common at all. Everybody's collecting the data though. Like every single one of the new farmers now that have, let's say, a John Deere combine has all the data they need. All of them are collecting them. All of them are storing them. There's a very small minority that actually is doing something with it. Most of these folks, what they do is they outsource it. They pay a company to do that for them. But the revenue that they get back does not justify it most of the times. Because those companies right now that are popping up like mushrooms, by the way, there are tons of rural companies that will do data analytics. So most of them don't do much. They give you beautiful satellite imagery with nice placement of your field and some ArcGIS maps that we computed last time. That's about it. Okay. There's no intelligence in 9% of these tools, especially the one from, for example, and I'm gonna tell him because I looked into their app and it just doesn't do anything. Like Climate Corp, which is basically on the top of these things because it's backed by Monsanto, still doesn't do much. It will give you early warnings of floods and whatever, but everybody gets those as well. Right? It will give you, that part of your field looks different than this part of the field, but they will not tell you what to do afterwards, or they will not tell you how they got that. Yes, sir.
I don't know how it's like here, but there, Climate Corp is like they have a lot of experience on fields, so they can use this kind of stuff, but to tell to the farmer or like to give to the farmer map for planting with different population on their fields. So that's one of the things they're doing. That's practical stuff.
Yep.
I'm not sure if they're doing the same.
They do variable rating in terms of like applications. They don't do variable rating in terms of seeds. Because here, if you're a corn farmer, for example, you buy only one seed. Otherwise, you don't get certified. So it's a big, it's, you know, and I heard it the other day that, for example, if you're doing rice, okay, you buy one rice variety, and that's what you put in your field. Because if you put multiple ones, then you're losing some licenses, or then you're not certified anymore to put that pesticide on top of it. So it's very tricky.
Even with the same hybrid, like in Brazil, they were planting with
Different rates. Yeah. So that is something that they do here as well. Different rates of planting, but not different varieties. And they also do different rates in applying nitrogen, organic matter, you name it. They do all that. I give you that. But of course, they will give you that suggestion, which basically is a map that you then put into your machine and you let the machine do it. 90% of the farmers don't know how to do that part. So even if I get a map back in ArcGIS, for example, that map tells the tractor when to increase the rate and when to decrease the rate. A lot of folks don't know how to program that back in. Okay, so you got to be all the way to the top to be able to do a couple of that stuff. The Hardwicks, which is a big family that's embraced digital ag, they're doing that, and some of the data that I have are coming from them.
I know that they have like kind of a black box inside of the tractor.
Yep.
Just like say, now I want to do this, and then you just
press a button.
Press button, play,
yep.
And then it goes to your tractor.
Still, in order for that to happen, you need to be able to calibrate, and people don't know how to calibrate. And then that's number one question for the extension agents right now. Can you help me calibrate my tractor? And of course, our extension agents don't know how to calibrate a tractor, so that's why we're probably going to have 1 or 2 sessions over the summer to do that. Because it would work if your GPS was calibrated. If it's not, then the tractor thinks it's next door, so it doesn't work very well. So people opt to not have the black box working at any point and do it traditionally. Even if you opt to have it off, it still collects data though. So the data is collected no matter what, especially if you're using John Deere stuff. And it's also uploaded immediately to the internet the moment that the tractor gets some sort of Wi-Fi area. So John Deere gets it too. So it's kind of tricky. We're in this situation where there's a lot of data out there, but there's not enough tools. All right? If you find some time, show up this week. We'll talk more about it.
I think like final preparation is the one that is the closest one to get something from their data.
True, and they already have one app that I like where you take a picture of a disease and it tells you how far along it is. They're trying to make it so that you take a picture and every disease can be identified. They're not there yet. But for example, last semester, one of my students did a project on that thing exactly, purple blight. So I was like, look, you can just hire her, be able to do it. That might happen, we'll see. Okay, back to our boring class. Nah, today's gonna be fun actually. What I want us to do is I want us to click on Daily Task 3 Level 2019. And I just want to impress you with this little tool for today. And there's not going to be a lot of learning. It's going to be mostly a lot of, wow, this thing works and it's fantastic. So what we're going to be downloading is a pre-trained image classifier based on convolutional neural networks. The only unfortunate thing about this guy is its name. It stands for You Only Look Once, not the other craziness, right? You Only Look Once, or YOLO, is a real-time object detection. There are tons of videos out there. Okay, it was first developed for, I think, C++, but I don't know. And Darknet, where it's written on, is an application in Python, and now it's also an application in R. We're going to be using the R version. If you'd like, spend a little bit of time looking at the ins and outs of YOLO. It's got tons of publications that you can cite. It's got this Darknet. It has nothing to do with the other Darknet. Okay, the nefarious stuff. No, this is just whatever. And this was written in C. Okay. So the background is a neural network, a convolutional neural network, and we'll see everything in practice. The cool thing about the R implementation is that they made it into a package. So we don't have to train anything. We just have to download the package and check out the magic. All right, so click on that link that I'm giving you now. That's a Google repository, and download everything somewhere in your computer. Yeah. The what? Mm-hmm. So just pay attention. I'm not sure if that's going to work, but yeah, go ahead. Give it a try. It's this yellow one here. If it works, good. If it doesn't, sorry. Okay, so let's go ahead and click on that folder and download everything in it and create a little folder somewhere. It is an R environment. It's relatively straightforward. It takes us more time to download the package itself than it is to run it. Let me also navigate there. Notes. And when you download and save everything, we will be working with the R code, obviously, which is called darknetclassifier.r. Now, download everything, please. And then let's open up the R code.
The darknet.
Yeah, the darknetclassifier.r. We're working with it. So open that one up with your favorite R Studio, and you will be greeted with this. Right? Yes? Cool. Everybody on board? Download this. Okay. As I said, it's going to take us a little bit longer to install it. There are some versions, there are some computers that might have a little bit of an issue of installing everything. That is the case. I'm sorry. I didn't get to YOLO today. It should work. I need one for this morning. All right, first things first, run the first line. I would like us to install the dlib. And if that works, then this second one should work as well. The dev tools install GitHub, blah, blah, blah. If that doesn't work, let me know and we will fix it. So run the first line and then run the second line. Do not run them at the same time. It first needs to install the dlib package, and then it needs to install the other package. The second part might take a little while. So to give you an idea of what's going on, the second one is actually going to a specific online repository and downloading the package itself. Okay? And it's not on the CRAN that most of the packages are, it's on a specific one. That's why we needed this depth. If you get an error, then it means that something is off. You raise your hand or become the Plus one. Yeah. Oh, that's downloading the sticks. That's for the relive. The other one takes a little more. Did it start the process? Yeah. So you don't have to wait for that to seem like, oh, installation failed.
It took me to this website and
What?
this
Yeah,
website.
that's reminding. Yeah, that should not be. Did it do it at the end when you installed it? Performing this in the class and yes, program website.
Oh, so don't click yes on the website?
No, you put no to that.
Okay.
Yeah, so- Hmm.
Yeah, we some kind of notification for.
Yeah, I got the same installation error. I don't know why. Probably because I have it already.
No, it tells me do you want to install that? It's not doing.
Yes. Why did I get it installation failed? What's that? Oh yeah, see, I already had the previous version, so I was just stuck. I hope it didn't delete the old one. We'll find out if it doesn't work. Okay. All right. So did it download and install, or are you getting it? Yes. I hope it didn't delete mine. That would be. Then I think install.
Yeah. Official, that.
Yeah, you use one.
No.
All these tricks fail. I think I'm running out of tricks, right? I figured out 3 problems. I fixed them. There you go. There you go. No, the world was taken over. Yeah, you need to. Yeah. Did it install? No. It doesn't have any of the depth. Right. Install that things again. Do it through that. And then you go around and set that. And then we're going to do run number 8. Why would you call that again? Run number 5. Run line number 13. Yeah. You run line 13. So you want to see the order. That's an error. Now you found it. Find that image. Yeah. Or find evidence on it. So then what you need to do, you see that one, change the C using that image. Right. For those of you that finished installing it, you can test whether or not you installed it by running line 13, which is library image document. I don't know what the website is, but it should not be the one on this one. But the thing is, look, it could be that they changed something in them to the Mac users. I haven't checked since the last time. This is not super crucial. Today's class is not super crucial. They probably changed something from the dev tools for Mac users.
Yeah, I'm trying to figure out, it's telling me how to get around it.
Gotcha.
But I just don't know how to get it.
Well, as I said, this is not very crucial today. Tiny YOLO or problem. It's just for me to showcase, look, this machine learning tool totally works and it's fantastic. All right, so what I'm going to do then, hopefully the folks that were able to install it did install it. And as I said, you can check if it was successfully installed by running line 13. That will basically ask R to read this library. And then what we need to do is we need to basically just go ahead and download the classifier from online. We're not going to be creating it on our own. This is borrowing the classifier that other people have created. To do that, highlight lines 14 to 17 and run it. So basically what we're doing over there is we're using a classifier that these folks have already trained. Okay? So we're bypassing that part. So YOLO tinyinvoke will be loading one of those classifiers, one of those algorithms that we discussed last time, that we discussed this earlier on. So they have literally trained this algorithm to distinguish cars, people, and bicycles and all that stuff. All right? And now what we're going to do is we're going to apply it to an image of choice. To do that, put your image preferably somewhere in the desktop. This is the one that I'm going to be using. Okay, a bunch of folks with their bicycles. Okay. And what I'm going to do, the only thing you need to do as well is put it in the desktop and just change this little path into whatever path that image is. Okay, so on line 18, change the path to match, you know, the path for your image. You don't have to put it in the desktop.
I downloaded a group this one, and then after
Run the second one.
I run this line again. So
Run the second one. One more time. Let it run and restart. I hope so.
now it's
Did you install that? Yes. Line number 3. Run that one. I'm going hard to plug in if it found it. Different versions, different computers, sometimes it works. But from the moment that it does, everything else is like one button fix. Now, it doesn't work good. I mean, we're not going to be using this program ever. This is not how we're going to do classification. This is just me showcasing, look, it works. Just one. So then the last thing that we need to do is very annoying, change the backward slash. Oh, in the back. The last annoying thing, the backward slash. There you go. No, yeah.
run these three lines, which should not be a problem. Do that. Now, go to the folder where everything is saved, and you'll see the new image. New image. The folder that you're saving this structural file. Whatever folder. That image is used. Yes. That's the first one. That's the one. That's one.
Now, the annoying thing here is that you have to change the slashes of the path to backwards. So
How do you set your directory?
right. So again, for example, I want this guy right here, and the easiest way to find it is go where you put it, right click on it, and hit properties. This is the directory. But when you put it here on line 18, you go in and change the slashes the other way around one by one. Sorry, that's annoying, but you know, it's the only thing you need to do, and then run these three.
Last time you showed one
All the way to the top, session, set working directory source file location. But you don't do it for this guy. You just specifically put the path. I tried to make it internal, and it still wasn't working. So I was like, screw it, we'll put the whole path. So put the whole path. Some sort of thing that they did not fix themselves. So you have to give it the path. It doesn't do it an internal path. So the moment that I run this, things happen. Some weights are being loaded. Classification is happening. I don't know, all sorts of craziness. And then now I have this extra picture here called predictions. And ta-da, these are the people and the bicycles. And good job. Now, it double counted a person. Right? You can see here that person. That's okay. I mean, this is pretty good. Found all the bicycles, found all the people, double counted one. That's fine. For an object detection that really works in like 0 times, fantastic. Kind of looks like you're hiding a bottle over there. I don't know. Let's not continue on talking about it because other. You know. Okay, that did not happen. Choose a different image. Right, did you not do it?
No, it didn't show up.
Very accurate. You need to learn more. Very accurate.
Let's figure out how this R from
There's no. But in your pocket. Wow.
Being allowed speaking.
Okay, no, it's reading it right. The problem is reading let's do this all over. See, we have 4 people in that room. 4 people, right? 3 people. Actually, 6 people. No, that's okay. I mean, I don't care if it's doing it wrong. Person.
Ah, yeah.
Car.
That's what I was doing.
Yeah.
Can you see yours? Yeah, you saw yours. Did it work for you? Yeah. Okay. Did it work for you? You know where it is?
After I switched to backslash, so whatever this is started working. I had like this I ran the water.
One there, very good.
And then
Download the classifier.
yes, so
That works.
and then this
Works so well. Okay, so that download the classifier. So let's run the last one. That one is not going to work. Let's see the arrow is yeah, this is the slash. Choose the slash again. What's the name of the thing that you will classify? What's the name of the choice of JPG? Yeah, if you're using mine, it should be yeah. It does not. So the path.
Oh wait.
But it'll be much better if you find your own image.
This code is already good, right? So if I add different features, it's gonna identify
Just whatever they have started out with. And these guys are able to figure out, as you see, people, bicycles, cars, and
I took a look at it and you could download another model like AlexNet. I tried, but it didn't work.
it doesn't.
So
And same folder as the R code. Go to the R code, basically go to the second folder. So I'm not looking through. I think this
that's
whatever the same the R code.
yeah. That's a good thing because we could put that inside some boxes. That's what we usually do.
Right?
Why is that? We usually put that inside of the boxes. Like reducing percentage or something like that. Because then you know that is how we certain that is wrong.
Well, there you go.
It could be like twice. I have like to wait like twice. I don't care.
They did find a car.
Yeah, it did not recognize this as a car. It's not a
That's
car.
not really a car, right?
Yeah.
See, the idea there is there are two processes. One that identifies objects, and the other one that classifies the objects. The classifier works great. The object detection doesn't work that way.
Yeah,
So the classifier, if you know that there's an object there, you can figure out what type of object it is. Figuring out how many objects are there, that's really tricky. That doesn't seem to work.
yeah. But one more little sad about you on when you are like programming that, you could like use a heat map to see where it does it the machine learning is focused on.
This is 100% machine learning. There is absolutely no program. Picking up objects is done blackbox.
No, I know, but you at least to understand what is it looking for, you include like a heat map, and then you know like what attributes it is working.
I like the way you think, but that's not how
I've already seen like when we were talking about deep learning, I've seen some heat maps for what the machine is looking for.
Sure. Not work. I'm sorry to disappoint you. This specific part does not work like that. Now, if you want to use it for semi-supervised learning with that, it also has I'm disappointing you. This is 100% unsupervised. Right. Annotated data. Unfortunately, we have zero ways of telling me, hey, this is an extra person. We have zero ways of figuring out what to do. Which is weird.
Because on Lansing, they use this kind of, but I think it's how do you say best semi-supervisor ones. Because then you can see like some maps on there, like X-ray images, and then you can just like, if it's looking for the wrong thing, you can just try to point them like it is wrong, you should look for that, and then like help it.
Yeah. So my supervisor, but this is unsupervised. There's nothing we can do to tell you.
It's just like you just get some people to classify
by hand.
Create some classified images in the raw ones and just throw that on there. Like on your it's a code, yes, it's a code.
Just one letter.
Yeah.
Yep, precisely. That's exactly what's going on here. Now, there's a good question. I mean, that's basically all I wanted us to do today and check this one out, but then talk a little bit more over it. What's going on here? Well, first, you need to do the object detection, and that happens more or less by looking at polygons and then try to check, oh, this polygon kind of looks like me. Let's assume that we have figured out the objects. The important stuff is the identification. What's a bicycle? What's a human being? What's a car? How can that be done? Guess what? You're doing it every day. When? Well, every time on Facebook, you put somebody's face, and you put the name of how you do the tag, you've helped Facebook's algorithm to figure out faces. Okay. So you have hand annotated, all the whatever tags you put over there, you have hand annotated people. Now, you're like, okay, I'll do that with people. People have names. Okay, that should be easy. What about cars? Well, every time somebody buys a new car, and I did it myself, right? I took a picture of the car, my new car! Exclamation mark, exclamation mark. The moment I did that, I had basically hand annotated a car. Now think about it. Have you done that in the past? probably in whatever social media. Google will find all of it. So every time somebody has posted, a public display of the car with an annotation of the car, that can be scraped, and now you have created an image of the car with a little name attached to it. And remember, we take pictures of cars from all sides, all colors, all makes, all whatever, and all of them have car attached to it.
When you have like that, I'm not like robot thing. Sometimes they have like some image that were classified before.
That
just
is
to-
gonna
to
go
know
away
if you-
very
But
fast.
then they come another with another one that they never like classified, but you are helping them to classify them.
Right. That's also another true, although CAPTCHA does not do that, but they could easily. And the best thing is, people have now been creating algorithms that will fool them. Based on these things. Are you sure you're a person? You've seen that when you have to click the cars? Yeah, now people have written neural networks that will fool them. Based on, as you say, people press it, they keep that. It's kind of fun. Anyhow, going back to this, so remember that I said in the beginning, you need to supply a data set which is annotated. So how is that data set being created? Well, it's created every time you use social media, every time you use Google. They are literally using your eyes, your typing to create those data sets. Tiny YOLO admits that. They have been using this non-proprietary data set that they extract from various sources. Facebook does that. It's actually in its EULA. Check page something like 30. And it says that you are helping it collect information about specific things to help it train the machine learning algorithms. That's what you're doing. You have signed to that, right? You said yes, I did.
Google rewards. It's kind of
Yeah.
something.
They have fun.
That's it. You work for them and you get some
You
reward.
can get some money if you just classify a couple of things. It's very expensive, but if you're not doing anything else on Saturday night, you just spend 3 hours classifying anything, and you get maybe like $10.
Remember the Facebook challenge? It was like a 10-year challenge. You posted Facebook.
I'll call Facebook say no, but yeah.
Okay. Anyways, a bunch of my friends started posting pictures of them 10 years ago and 10 years now. Like
Okay, yeah.
present picture and then 10
Right.
years ago, side by side, posting it all like for weeks.
Mm-hmm.
And then someone said on Facebook, "Oh, this is probably Facebook just resetting their algorithm because they can't keep up with
Probably.
aging."
Probably.
So
Or getting more information about how to track aging
yeah,
for people. Yeah, absolutely. Challenge.
your challenge, very workable.
So that's how these classifications have happened. Now, why is it so successful? I mean, in this case, you have to agree that, come on, you picked up as many bicycles as it could, as many people as it could. Misclassified one object as a person when it's a bicycle, basically. But it still picked 4 objects. And you notice that it took it no time. So actually, Tiny YOLO can be used for videos as well. Because what is a video, right? It's snapshots attached to each other. So it will literally classify all of them and then create a new video with all of them. And since it's doing it that fast, you can literally classify videos. As a matter of fact, in the link that I showed you in the beginning, it has YouTube videos where that is apparent. Like people with dash cams will walk around and say, yep, vehicle coming through it, just monitors it. And they're doing that to say this kind of technology can be used to simplify all these automated driverless cars. And all. That's basically one way to use these things. Right? Something pops up. Is this a car? Is it a pedestrian? You can find it. But the reason why these things are working now, and that were not working 30 years ago, is not because we didn't have the machinery to do it. Okay, like whatever my computer did now, maybe 30 years ago we needed a whole room of computers to do, but we still have the capability to do it. What we did not have is a data set. What we did not have is we did not have millions of images of cars, millions of images of people, millions of images of bicycles available. So it's literally not the code nor the processing power. It is the data set. That's how I'm going to bring it back to the class. 30 years ago, all these things were not relevant in agriculture. Okay, 30 years ago, we did not have that many images. We did not have that many data sets. Now we do. So it does make sense to look to the future and say, hey, all this is working for everywhere else, and now I'm getting the data. So perhaps I can jump around a little bit and be a little bit forward in terms of these applications. Because now the data set is there. It's a matter of how to get it, or at least how to be able to work with it. That's what I think is the honest answer here. Because if you get a job, for example, for climate work, you will have access to all this data. Right? Or if you get a job at a university, you will have access to a data set. I mean, we have access to this data set. We just don't have enough time to process it, or we don't have enough knowledge. But it works. That's the idea. It works. And, I mean, this is a gimmick, but you can now start thinking about how you can apply that in real-life situations. You can figure out where the tree, for example, is in the field and tell, your combine to move around. Or you can figure out if there's a person running in front of an automated tractor, then the tractor will know how to stop or whatever. Things like that. I mean, this is like reason number one why these things are also redundant system in automated cars. Something walks in, the car needs to stop. How does it do that? Well, there's a classification that happens.
I think I saw the commercial that one company that does this soft, like wood soft, they use us to identify fingerprints.
Really?
So,
And then stop when the finger pops up. Yeah, that makes a lot of sense. Yeah. All right. Are we clear? Are we okay with this construction, this configuration, this whatever? All right. Now, in preparation for tomorrow, by the way, for those of you that were not able to install it, don't worry about it. We're not going to be coming back to it. This is basically just the show. I wanted to make sure that you've seen at least one code do it, but at some point we'll create our own. Okay, we'll create it from scratch and in Python. And it's actually going to be working on whatever data set we want it to be. This only works for people, cars, some objects, and some other stuff. Okay. All right. So in preparation for tomorrow and the week after that, I think we can start with part 1. Now, unless you have any questions. Okay. So what we're going to do starting tomorrow and probably finishing Monday is we're going to create our own machine learning tool that's going to be able to figure out cats from dogs. Because, come on, we get to see thousands of images of cats and dogs. That's already a great project right there. But this was actually put forward as a task to do for this competition online through Kaggle. We'll talk about that today as well. And it was one of the successes for convolutional neural networks that outperformed any other software out there in the classification of cats versus dogs. So this will take a little while. Let's go ahead and start today. We will also use the desktops in front of us because we have to do a bunch of stuff. So besides your laptop, boot up your desktop. And we're going to spend much of today setting this thing up. And we'll probably have to stop halfway through it and continue on looking. Right? There's only one setup that needs to happen. And after that, everything.
You're gonna need the anaconda setup, right?
Sorry. Let's fire up your desktop. You're going to need to follow some instructions. And we'll need the laptop as well to apply those. Now, this is definitely dead. It's no minutes. Give it another try now, and if that doesn't happen, then we have day of I mean, of course, we don't have internet connection. We can't do it. All right, so
Plug it in through there.
I'll look for it moving around. Okay, so what we're going to do is we're going to have the version of Python that we have to install some libraries. We will need the library Keras and the library TensorFlow. So that's going to take a little while. And I want the desktop in the background because it's going to help you move along with this step-by-step process. Now, if you look at the link that you'll find in step 2, spend one moment to look at that link. The link itself is a little bit important. Right. So this is one of the best step-by-step processes you have with Flowcharts. We've already set up Anaconda, so we can skip that part, but we'll navigate it. So I would strongly suggest keep that in the background so that you can check it. We've already done the setting up of Anaconda. We're not going to be doing the rest. Hopefully we will not run into any trouble. But if we do, there are some tricks. Okay, so now fire up your Anaconda environment in your laptop. And it does make sense to create a new environment if you haven't done so. You can call that environment to your lab. If you don't remember how to do that, I'll tell you. Fire up your Anaconda. You had promised me last week that Anaconda works for everybody. Anaconda Navigator. And you can fantastic. So go to your Anaconda Navigator, up, and we'll go to environments, and do one if you haven't done that already. Environments. So we'll add things into that. So if you have not created an environment, go ahead and do so now. Click on the environments. I think we've created one in the past, but just in case you don't have it,
Can we use the one we used?
yeah, that's what we're going to
Oh,
do.
okay.
So if we don't have, I would call it
Yeah, that's what I want.
all right. So you should have an old environment, yes? If you have an old environment, that's where we're going to be putting things. So you can skip all the way down to 3. We've done all the other stuff, right? And as a matter of fact, you can even skip down to where it says activate deep learning. But in order to get there, here's a trick that the Windows users can do. So this is just for the Windows users and you might help. You can bypass this completely if you click on Anaconda prompt. As a matter of fact, let's do it right now. But if you want to be able to do this from your command prompt, you can follow the right now, what I would like you to do, if you have the environment created, go ahead and Again, instead of using Anaconda Navigator, start typing Anaconda prompt. Anaconda prompt. We're good. Do Anaconda prompt. You have to black and start typing Anaconda prompt. Yeah, it's going to give you a prompt. This black window. Start typing in the bottom left corner, right here, Anaconda prompt. Anaconda. And more. And we don't care about the other. You already have it in the lab, so we use that. Cancel this one. Use that one. The one that has an underscore the other. Use off the one with the underscore. Yeah. I just wanted us to see it. You have it.
Oh yeah, I don't know if I'm with
Anaconda phone. Yeah, I mean, you guys should have it on okay. It's an Anaconda phone.
It doesn't show up in the comment.
Then
It shows it as something different, but I can't. I'm trying to remember. But it's just a black little box.
Sure. Go back to that navigator.
Oh, the navigator here.
Right click on that.
No. I mean, I'm clicking. I'm clicking on it.
Yeah, let it.
Oh, here we go.
Open terminal. That's right.
Okay. Thank you.
You can do it multiple ways. You can get this right here. Now, for those of you that are in the font now, the black box, you have to do activate and the name of the environment that you want to use. I guess most of you guys were using visualize. I don't know, whatever you named it. It needs. Oh yeah, activate space and the name of the. Right, activate and the name of the environment that you're going to be putting. If you did it right, press enter. It used to say base in a parentheses and then the command prompt. Now it should say the name of the one that you chose to realize. Right? So remember what's the idea here, right? You don't want to be putting all the packages in one big box. You want to put them into separate ones based on what we're going to be doing. So we're going to be installing things only in the visual add folder, not the journal. What we want is basically the package carrots. So we can skip Python, Jupyter, Pandas, and SciPy, but what we want to do is we want to install carrots. And to do that, what we're gonna do is we're gonna write, where is that? Conda, sorry. Try first. Conda install Keras. Conda install Keras. Conda space install space Keras. Conda install Keras. If it works, good. If it doesn't work, works here. Did. If it does, I will take it to this which says proceed, whatever, say yes.
It says it still on activate deep learning, and it says it doesn't recognize that.
You don't have to activate. You
Oh.
already did it.
Oh, okay. Never mind that.
That's right.
Okay, so you're failing. Then what you do is you do conda install TensorFlow. Conda install TensorFlow.
Fails.
It's never worked.
No, it takes a long time.
I'm still like,
What did I say about the
I have to
conda install TensorFlow? Okay, so about that. Now, it will prompt, if it works, it will prompt you to say yes or no after installing the environment. Otherwise, it's going to say, like, I can't do any of this. If it prompts you to install it, just press yes. So we have connection error. Oh, sorry. Still solving the environment. Okay. If solving the environment goes on for like 10 minutes, you stop it and we'll figure it out. In fact, again, okay, install, sorry, pip install dash dash upgrade and that's in that. Pip install. Honestly, the hardest part again is to install the package. When we have them down, you'll see that the code is sweet and simple and straightforward. That's a question I've made once in my life and it's not stable, so you need to do that. How do you make it happen? Try to make tons of fun. You make function not as very simple. Suppose now that you have 30. Instead of like sending out the bunch of stuff, this thing comes up, that function. That's basically what's happening. Stability comes from the fact that you have waited so flexible.
example, what function value? Define the biggest value of the set or evaluation of it. I made it so that phase A is square. And what is some of the function in the whole point is to make it as flexible as possible. Functions are valid. What happens is at some point in the year, collecting these functions. Very easy formula. You know that we have. And then we make it and we want to get a special time for the process happens. Script with a lot of ifs and okay, so if it's prompting you to accept something, go ahead and press yes. I promise you, this is not taking you to the machine yet. And if the conda install carrots work, then we're good to go. If it didn't work, pip install TensorFlow. And when that finishes, pip install upgrade. That worked. That worked. So, for those of you that installed Keras, go ahead also and try to conda install as well. For those of you that finished the conda install Keras, you should also conda install Keras. Now, if you try to conda install TensorFlow and it says all of them are installed already, if that gives you errors, then we need to uninstall everything and install the TensorFlow. Well, back to the already installed. Yes, sir, you have completed this process. So you have installed this. I'm ready to go out there and issue I'm going to install black code. Now, Keras takes so long because it's such a huge package and it is already built on TensorFlow. When you want to install Keras, it automatically knows to install TensorFlow. If that failed, then you have to install TensorFlow. Yeah, now you also install Keras. So then we can do, let's check this environment. Keras installed. Okay, and Alright, very good. For those of you that installed it, congratulations, you finished the big chunk of trying to install Keras. But for those of you that didn't, sorry about that. I'd like to see you though prior to tomorrow's class because we're just going to keep on hacking at it. The rest, I think we should wait for tomorrow. But if you run into trouble in the installation and you want to give it a look tonight, check steps 3 and 4, okay, on the daily task. And then tomorrow, we're going to create some accounts, download the images, set it up, and see how we can move forward, okay? That's it, folks. For those of you that really, really want to download Tiny YOLO, I can help you with that as well.
Can you just exit out of this?
Yeah, everything is saved. The moment that you installed it, it should be there. Sorry. Yeah. Okay. So once again, for those of you that were not able to install Keras, try steps 3 and 4 on your own. For those of you that want, you can come in a little bit earlier tomorrow and we can check whether or not it worked. And if you want to see Tiny YOLO, you can come to me during our stars meeting.
So Wi-Fi has issues.
Right click on it. Oh, yeah, you have to get it first. Right click on it. Yeah, open it. Show the loop works. Here. Yep. Now, commit. That one. And your username and password. This one, the full username with the HTTP.
In the end, they told me Paris was terrorism. So here I did Paris. And it says successful installed, but it doesn't say that. So this is the one. It says successfully built Charles Farm Gas. Okay, and then it says successfully installed. Okay. Okay, cool. All good.
It seemed that you did it right.
Oh yeah.
And you already have it. Yeah. This is more than this. Paris is installed. But I mean, tomorrow you might nag and say, "Oh, I don't have this package." But since you use content installed in the work, yeah, we want to install something. Problem is when you so why is content installed? Content install a package, it installs all the other packages that are needed. Sometimes when you do pip install, which is it forgets to install itself. Content install will never forget anything. They will do it so that you actually just do it. That's it. It's much easier to just do content. So when you do content install, it already also installs Tensorflow. That's it. Because Keras does not work without content. If we were to do it like the one that I described in there, we have to do pip install TensorFlow first. If you run it, it's probably going to tell you that's like my test.
I was not saying that's what I didn't.
You try to contact install
Then we have no. This is a mouse that does not work for anything because you cannot click. You just come around with it. You can't do anything.